This question is about a titration experiment carried out by a group of students to determine the concentration of a solution of ethanoic acid using sodium hydroxide. A student weighed out about 4 grams of sodium hydroxide pellets and added them to a beaker containing 50 centimeters cubed of deionized water. The mixture was stirred with a glass rod to dissolve the pellets and give a homogeneous solution. The solution was poured through a funnel into a 250 centimeter cube volumetric flask. Deionized water was added up to the mark and the flask was shaken. Describe how you would ensure that all the sodium hydroxide was transferred to the flask. So it's asking you to describe the process of washing equipment into the volumetric flask. So you need to talk about rinsing the pieces of apparatus. So rinse the glass rod, so you dissolved it with a glass rod, beaker, and funnel, transferring all washings, all rinsings into the volumetric flask. A student adds deionized water above the mark and shakes the flask. Suggests why the whole procedure has to be restarted rather than using a pipette to remove the excess water. So what we need to understand is that removing the excess solution, because we've shaken it, will remove some of the sodium hydroxide. So we won't know the exact concentration anymore. Two students each cleaned a burette, then poured sodium hydroxide solution into their burette. So we're assuming they've cleaned it properly. Student 1 used a funnel to pour sodium hydroxide solution into the burette, gives 2 steps needed before taking the initial burette reading. The first step is we need to fill the tip of the burette, the jet space. So remember that your burette has a bit that comes below the tap, and that would be empty until you fill it. So the tip or the jet space of the burette must be filled with solution. So what we're doing there is we're removing any air bubbles from that tip. And then we need to remove the funnel, because if the funnel drips during the experiment, that's going to change our burette readings. You should maybe also talk about making sure your eyes are level with the burette before you take the readings, and then making sure the burette is vertical. Student 2 cleaned the burette by rinsing it with deionized water immediately before filling it. Give the effect, if any, on the value of the first titer. Justify your answer. Well, if you don't rinse it with sodium hydroxide, if you just rinse it with water, the water dilutes the NaOH solution. And if you dilute the solution, you're going to need more of it. So the titer will be larger. Each student used a pipette to measure 75 centimeters cubed of ethanoic acid into 4 conical flasks and added an indicator. The results of the students' titrations are shown. We've got to complete the table. So the first thing we need to do is do the subtraction, remembering to keep consistent, not nearest 0.05 all the way through the results table. So don't be rounding numbers to say 12.5 and 12.4. We need to put the 0 on the end. Then we have to tick the concordant titers, the ones within 0.1. So we're ticking the middle two here. The low titer for titration 4 was queried by the teacher. The student wanted to refill the burette and continue the titration, but had been told the measurement would increase if this was done. Calculate the total percentage measurement uncertainty if the burette had been refilled to naught and then a further 0.3 had been added. So in total then, there was 12.1, but we would add 0.3, so the total burette reading would be 12.4 centimetres cubed. But to do that, we would have had to read the burette, look back at, we would have read it at 37.9, 50.00, filled it back up to 0.00, and then emptied it to 0.3. We've read it 4 times. Each has an error of 0.05, and we read it 4 times. And the total measurement was 12.4. So as a percentage, that is 1.6%. The teacher carried out the experiment and obtained the following results. They, into 250 centimetres cubed, put 3.8 grams of NaOH. They then put that in the burette. So this was our NaOH. And we used 11.9 centimetres cubed as the mean titer. When they titrated it against 25 centimetres cubed of ethanoic acid. So having a look at our data, this is ethanoic acid, so that's this one. And all the other numbers, this 11, this, and this, these are all of our NaOH, which is here. First thing we're going to do with the mass, formula, and volume is find moles, then concentration. So moles of NaOH in this flask, 3.8 grams divided by the MR of 40. So we can work that out on our calculator. 0.095 moles in this flask. We then dissolved that NaOH in 250 centimetres cubed. So if we turn that into decimeters cubed, we can find the concentration, 0.38 moles per decimeter cubed. So this is the concentration of the NaOH that we used, and we then in our titration used 11.9 centimeters cubed. So the moles of NaOH in the titration, 11.9 into decimeters cubed times by 0.38. So you want to get your calculator and do that. So 4.52 times 10 to the minus 3 moles. Now we can use the balanced equation to get the moles of ethanoic acid according to the ratio. So that's the same. So we can find the concentration in moles per decimeter cubed if we divide by the volume. And we had 25 centimeters cubed of ethanoic acid. So that's 0.181 moles per decimeter cubed, but our answer is wanted in grams. So what we need to do is times by the MR of ethanoic acid. So we're going to times this number by 60, because that's the MR of ethanoic acid, and we're going to get 10.85 or 10.9 grams per decimeter cubed.